Hello everybody. We are going to continue our coding worksheet 2. I'm going to discuss questions 1 all the way to I think 10, okay, for this particular lesson. For the rest, right, I'll continue tomorrow, okay. So before we do that, let me just review what we have learned for logarithms. Now, very importantly, logarithm, right, you need to know is like the inverse function of the exponential, or what we call the index form. Okay, so if I were to write y equals to a to the power x, this a is the base, this x is the exponent or the index, okay, and of course this y is your answer. Now, if I were to change this index form to a logarithmic form, then my base is here, the number written here, and this x here is my index, okay, and this y here is my answer. So if I go in a cyclic fashion, a to the power x equals to y. All right, this is which is what is on my left hand, left finger, okay. And very importantly, you need to know this, okay. You cannot ignore this, because if you ignore these conditions, you will have problems plotting logarithmic graphs later when I go through the logarithmic graphs, okay. So you need to know that your a, your base, has to be positive, more than 0. Okay, your a also cannot be 1, because if it's 1, then it's not defined. If you are not sure, you refer to the previous lesson. And your this y, right, okay, what we call the argument of the logarithm, must be greater than 0, because when you take a, which is a positive number, to the power of something, it has to be positive, okay. So these 3 conditions, please know it very well, and you must be able to switch from here to here without any problem, okay. Now just quickly go through, recap what we've done. This one, okay, the change of base, you can change to any base you want, okay, and in this case I change to base c. Okay, then this is the power law, where I can bring the power of this whole argument down, okay, to the front of in front of the log. Okay, then we have the product law, meaning if you have log xy to the base of a, then you can split it into this, okay, quotient law. And there's something I didn't go through that time, but I want you to take note, so please take a look at this following section. Okay, let's say okay, actually I show you this example, which we did, I think, last lesson. Okay, so remember we solve this, solve, then make the base the same. Then once the two base on the left and on the right are the same, we can just take this argument equal to this argument, right? So I think this was what we did last lesson. Now, this is actually something that you will use very often, and this is exactly what I've written here, okay. Now, if you have log of x to base a equals to log of y to base a, both the base on the left and on the right are the same, then you can say that this argument on the left is equals to this argument on the right, and then you can solve the equation accordingly. Okay, this is just a simplified form of what we did last week. Okay, so this you have to know very well, and using this, right, I'm going to show you another so-called it's not a law that you need to know, but it's good to know, because sometimes you can actually use it when you solve equations, or when you simplify the log expressions. Okay, let's take a look. Now, ignore this, okay. Let's say I just have this log of x to base a equal log of y to base a. Now, don't you agree that using this, this base, right? This is the power, right? A to the power x equals to y, which means you get this. Okay, so if I have log of something equals to this, I can rewrite in index form as a to the power x equals to y, correct? Okay, so this is what I want to show you here. So instead of just equating the two arguments, right, x equals y, I can rewrite this as x, okay? As here, I write here, x, okay? This argument, x. That means I get rid of the log, I get rid of the log. X equals to a to the power, this whole thing is a power, right? So don't you agree it's like that? Okay, if you think about it, yeah, these two are equivalent, okay? This and this. Now, the interesting thing is that you know that this is equals to this, okay? Which means that x equals to y. So x must be equals to y, which means that whenever you have a base to the power of log to the same base, okay, it must be the same base, then you can simply think of this as like the opposite of each other, and then the answer is just y. That means the right hand side, the answer is just y, okay, which gives you x equals to y lah. Alright, now let me show you exactly what I mean. So let's say I have a to the power of log of y to base a, right? This a to the power of log base a, right, actually cancel each other out. Then your final answer is is y. Okay, so let me give you some numerical example. Example 1, if we have base 2, right, then to the power of log of base 2, this base and this base same, right? Sorry, this base, correct, this base and this base same, then you can think of this as cancelling each other out, so the final result is this. Okay, another example, 5 to the power of log 2p to base 5. You see, this is base 5, this is base 5, so they cancel each other out because index form and logarithmic form, they are inverse function of each other. Okay, so your answer is just this argument here. Alright, now this one, okay, you have to be a bit careful. Because of this 2 here, right, you cannot just say that, oh, it is 2p, cannot. You have to bring this using the power law. Okay, remember the power law? This one, the power law, right? You can bring up, can bring down, can bring down, can bring up, right? Okay, you use the power law. You bring these two up here, okay, then it becomes p squared, right? Then when this number here is 1, okay, it means that it's 5 to the power of log base 5 here, right? Then you can remove the log and this power, and the final result is just p squared. Okay, so sometimes you may find that this is very useful to you. All right, so I have shown you how from here, okay, you can actually rewrite as this, and how this actually gives you this same result. Okay, so this is something useful which you can use if you need to. Alright, okay, having this background, I'm going to start today's so-called lesson. Okay, it's basically just going through the solution. So anything you're not sure, you can PM me. Okay, I will not go very fast, but some I may go fast. Okay, so all this while you have been doing indices and all that, you must understand that you actually do not have the true picture of indices. Why? Because indices, sometimes when you solve it, right, you need to use logarithm in order to help you to solve it. Using indices alone will not help you to solve certain questions in real life. Okay, so actually by right, you should study indices and logarithm in together lah, in conjunction with each other. But never mind, we'll do it now. Okay, so This first question is purely on log, but you must know that as I mentioned before, to solve log, right, sometimes you need to change to index form, or to solve index form, right, you sometimes have to change to log, or you have to use both. So you have to be very conversant in both of these indices and logarithm. Okay, come, solve solve this plus this equal this. Okay, so then one look at it, you see, oh, all the base are the same. That means you don't have to change the base at all. Very simple. But we have a problem, and the problem is that there is a 2 here. Okay, if there's a 2 here, right, it makes things a little bit not say complicated lah, but you cannot have 2 here and then you combine this with this. All right, what do I mean now? Okay, see, log of this plus log of this, you know, you can use the multiplication law and you can write it as this, right? Okay, because they are both to base 3. Only when they are the same, having the same base, then you can do this. 2 times x plus 4. Okay, and you must put bracket. But what I meant just now was you cannot have a 2 here and then you combine with these fellas here. Cannot. You need to use the power law and bring the 2 up here so that the coefficient of the log on both the left and right are equals to 1. Okay, so only that then you can remove the log of base 3, okay, and then equate the 2 arguments, and then you solve accordingly using your algebra. And as I mentioned many times in the previous lesson, you always have to check whether your answer is applicable or not. What do I mean applicable or not? So you check, when you put 4 inside, no problem, right? It satisfies all the conditions. What condition am I talking about? All this. Okay? You need to satisfy all this. And your A must be positive and all that. You must satisfy all this. So when I substitute minus 2 inside here, right, I find that it doesn't work for this particular log because I cannot log a negative number. Okay, that's why I need to reject this. Now, a lot of students lose marks in the exam because they fail to check their final answers. They simply do, and then they move on. No, you need to check. Okay, so that's for question number 1, very straightforward. Okay, now number 2, almost the same. Almost the same. Again, very simple. The base is 3. Alright, so I'm going to show you 2 methods. The first method is this. Okay, let's focus on the first method. First method, right, what I'm doing is I notice that, oh, there's a number here and there are 2 other terms with logarithms. So I go and combine the 2 with logarithms, okay, and then I end up with this, okay, using the quotient law, right? This divided by this, okay, for the argument. And then now what I do now, right, is I change this 3 square equals to 5x squared plus 1 over 2x plus 1. Then I use algebra and then I solve. Okay? This is one method of doing. The other way is I change this. That means I change everything to log. Yeah. Just now this number I left it as it is, right? Now I change this number to log also. Now how do I do that? 2 means 2 times 1, right? Because 2 times 1 is 2. Okay, so you should know that log of 3 to base 3 is 1 because 3 to the power of 1 is 3. Okay, but as I mentioned to you, I cannot have a number here because it will not allow me to combine this log with the other log. So I bring this power up, I square it, becomes a 9. Then I combine these two. 9 times 2x plus 1 becomes this. And then once the log, the base of both sides are the same, right? In fact, they are the same right from the start. I can use algebra again. And then when I check my final answer, there's no need to reject anything. Okay, then I am happy and I accept both of these answers. Okay, now that's for question number 1, part 1 and part 2. Now let's do part 3. Okay, part 3, I'm showing you two ways also. Part 3, actually it's about the same lah. Okay, I'm giving you straightforward questions first. So, first method is I combine all the log together. So, minus 2 log x on both sides, plus 2 on both sides. I'll end up with this. Okay, now this cannot be combined with this now because you need to bring the 2 up. Only when the coefficient of log is 1, then you can combine these two. Okay, there is an exception to this. Next time I'll show you, okay? Next time. Now, once the two log have the same base, which they originally already have, and the coefficient of log is 1, right? I can combine these together, and then using 2 to the power of 2, okay, 2 to the power of 2 equals to this, right? Then I solve, and then get the answer. And I double check, Okay, when I double check, right, when I sub in x equals to minus 3 over 4, it doesn't fit in here. Okay, because I cannot log negative numbers, that's why I reject this. Alright, okay, so that is what I have. Now, if I make any mistakes in my solution, just let me know. Okay, the second method is to change everything to log. So what do I do? Okay, something seems wrong. Yeah, nothing wrong. Okay, I multiply 2 by 1. Okay, to get the minus 2 here. Alright, then bring this power up. Okay, becomes 4. So once the two base have the same value of 2, then I continue and then convert it into algebra. So that's all. Okay, so that is part 3. Now let's look at part 4. Okay, part 4, LG, LG, maybe I just add in here. What does LG mean? LG simply means log to base 10. Okay, so whenever you see LG, right, it means log to base 10. So let me add in here. Okay, just now I didn't go through this because I want to go through now. Now, if I write LOG, right, it is the same as LG, and it is the same as log of to base 10. Okay, these are all short form. You will see this LOG in your calculator. It means log to base 10. LG also. You won't see this in your calculator, but you can, in your working, write just LG. Okay, they both mean log to base 10. So the logarithm that you can calculate using your calculator is this log to base 10, and also log to base e. E, if you remember, is the number you learn 2.718 something. Okay, you check your calculator, then you can see the 10 digits of this e. Okay, this is what we call the natural log. We will discuss more when we go through other questions. But it's what we call the Naperian constant. John Napier came out with this. Is a number that occurs naturally. Okay, we actually did that when we were doing indices this year. Okay, I hope you remember. So remember, when you see log or LG or LOG, it means log to base 10, and you can actually calculate this. Okay, using your calculator. That's what I meant. This one also you can calculate using your calculator. Okay, now let's continue. This particular question, right? This LG means log base 10, log base 10, log base 10. Now there's a 1 here, so I again show you two methods. You can either choose this or choose this based on your preference. But actually, I think easier is the method 1. Alright, because you simply combine those with the log terms. Okay, when there's a negative, right? When there's a negative coefficient, you simply put the argument at the denominator. Okay, and when the coefficient is positive, you put the argument at the numerator. That's all. Okay, and LG means log base 10, right? So 10 to the power 1, and then you solve, and then you get the answers. Again, check, check. Okay, so these are all like drill and practice questions. You just do, you get a hang of it. Nothing difficult about all these questions. Okay, nothing challenging. Okay, now let's do the next one. Now the next one then slightly challenging. They asked you, what's the question? Question number 2, right? They say given log of this and this equals this, find the log of this. Okay, so there are two ways to solve this question. One way is to convert this logarithm, right, into exponential form. This one also convert to exponential form, and then later once you have found x and y, right, you will be able to substitute x and y inside, and then you find the log of square root x times y. Alright, the other way is to work in logarithms form, and then again you solve simultaneously, and then you come up with this. Okay, I'm going to show you both methods. You need to try both methods because sometimes, right, the question may ask you to, may force you to use any one of the method. Okay, so just practice. Okay, this I rewrite as a to the power, a to the power of 4.5 is 9 over 2, right? Equals to x over y. Okay, same thing here. A to the power of 5 equals to like that. Okay, so I get one equation, two equations. The whole idea is to get simultaneous equations, and then I solve it. So in this case, right, I am making y the subject. You can make x the subject also. You can try making x the subject, and then you see whether you get the same answer as me. If my answer is wrong, let me know. Okay, so sorry. Okay, so as I was saying, right, this is a to the power of this equals this. Then a to the power of 5 equals to this. Then you get two equations, and then make y the subject. Then I sub 1 into 2. I sub this y into here, so as to get rid of the y, then I find x. So you see, you are practicing indices here. Okay, sorry. Yeah, practicing indices here, and you will notice that in a typical question, right, you cannot say don't use index form or don't use logarithm form. In a real life question, they will require you to be able to change from here to here, here to there, and then you solve accordingly. Okay, so I'm going to sub this answer, not this answer, this x value into here, and then I find y. So now you see, once I found x and y, right, I can go back and find this log of x y square root. Okay, now log of xy square root actually means, remember this one means power 1, this one means root 2, right? So it means half. You must put bracket. You don't put bracket, right, we will not mark you correct or mark you wrong. Okay, now within this method, right, there are also two different ways to find the final answer lah. Okay, so the first way is I bring down the half, then log of xy to base a, I go and split it. Why split it? Because I know that x is a square, I know that y is a to the power minus 5 over 2 from the previous working. Then I can bring down this, bring down that. Okay, bring down. You know the power law? Then you get this, right? And then this log of a to base a, log a to base a is just 1, right? So the log disappears. And then you get this, and then you get minus 1/4. Okay? Now, method 2 is simply like that. I simply sub in x and y. Okay, because I already know the x and y answers, right? Values, not values, the what is equal to. Then you just go and take note. a to the power of 2 times a to the power of minus 5 over 2 is 2 minus 5 over 2, okay? 2 minus 5 over 2, let me just write here. 2 minus 5 over 2, right, is minus half, okay? Minus half, then you times half is minus 1/4, okay? And then you bring this power down to here, and then log of a to base a, of course, is 1. That's how you get the answer. Alright, so do practice. Even though you can get the answer, maybe you use this way, you can see that it's much shorter to use this method. Okay, so that's method number 1 for solving this question. Now, the second method is this. Okay, second method, right? Just now I converted this into index form, this into index form, right? Now I don't convert them to index form. I work with log. All right. So using the quotient rule or quotient law, sorry, quotient law. This will be this and this will be this, right? Then what do? I you see in my working, I actually times 2 throughout lah. How do I know I must times 2, right? Actually, what I did is after I have split this into 2, right, I actually stop here. I stop here. Okay, I didn't label 1 or 2. I didn't. Then I continued with this. Okay, split this using the multiplication law. Then I find that there's a 2 here because when I bring it down, right, there's a 2 there. Oh, okay. Oh, by the way, why must I bring it down? Why must I bring this down? Can I don't bring it down? Okay, I brought it down because what I want as the final product, right, is this one, xy. So it's like power 1, power 1. So I don't want this power 5 and 2 to interfere with my working. Okay, so that's why I brought it down. And because I brought it down, it also gives me the opportunity to solve this like a simultaneous equation. Okay, so you see the 2 here. That's why I multiply this throughout by 2 to eradicate or eliminate this log of y to base a. Okay, so I add 1 to 2, and then I end up with log of x to base a. Then I can find what is log of x to base a. Then I sub this into here. Okay, because this whole thing, which is this thing here, right? It's just 2, you see? Then I can find what is log of y to base a. Okay, then once I've gotten this and this, okay, I can find this. But of course you must know that this whole thing is xy to the power of half, and then the half you can bring down using the power law, and then this is just this plus this, which is this. Okay, this plus this is just this plus this, right? Okay, so just put in to get the answer already. Okay, so that's all so these kind of questions give you a lot of practice on, in fact, a lot of the laws so that's why I put in quite a few of these kind of questions. It will really help you familiarize with the laws. Okay, now let's move on to question 3. Okay, question 3 question 3, what did they ask you to do? Oh, given this, given this, and that y equals to 9 when x equals to 2, right? Then y equals to 37 when that means they give you this main equation, right? Just now they give you 2 equations. Now they only give you 1 equation. Just now they give you 2 equations, number 2 They give you 2 equations, then they make you solve the 2 equations simultaneously, right? So that's one way they can set Another way, right, is they give you 1 equation only, but they give you 2 sets of values. This is one set of value, this is another set of value, right? They give you 2 sets. You sub one set here, sub one set here, then get two equations already, no? Okay, then you can solve simultaneously already. Now, this question involves a lot of index form and logarithmic form combined together. Okay, so you see this dot here means multiply. Okay, if you're not familiar, you use bracket. Okay, now you see how do I get rid of either the A or the B? The only way is to divide. Okay, the only way is to divide. So that's what I did. I divide 2 by 1. You divide by 1 by 2 also same. Okay, now I've divided already. I changed the 4 right to the same base here as 2. So you end up, I end up with 2 to the power of 2b. Alright, and 2 to the power of 2b over 2 to the power of b, right, is just 2 to the power of b. Okay, but now I have a problem. You see, this is what I mean. You see, all this while in Sec 3, you are like, you're like not experiencing the full spectrum of possible questions. Why? Because all the questions that we give you, you can change to the same base. Correct or not? Because we have not taught you logarithm. But now that we have taught you logarithm, actually in real life, right, don't have same, not say don't have, it's not always same base. Correct? So in this case, base 2, whereas this is 37 over 9. You cannot change this to base 2. So we have to take log on both sides. Okay? You take log on both sides. And that's what I end up with. Alright? I log here, I log the left, log the right. And why do I choose log base 10? Because log base 10 can be found in my calculator. Okay? I do go and choose log base 2, then I cannot use my calculator. Alright? And why don't I use ln? Okay, ln, right, is reserved for the number e, the constant e. So the later part I'll show you. Now, when the this number here is not e, right, you don't go and use ln. Okay, later I'll show you when we come to the question. So once you have done this, you use the power law, bring this b down. Then this log 2 is just a number which you can press the calculator. Okay, then you get the answer 3SF. Okay, and once you have found b, you can use any one of these. Any one of these. Okay, sub into any one of these to find your A. Alright, but of course you must remember you have to use the 5SF value. Okay, you cannot use the rounded off value here. Otherwise we'll minus 1 mark for accuracy again from you. Okay, so that's all for number 3. Now let's go to number 4. Number 4, it looks like we are back in business. It looks like we are back to something we are familiar with. Okay, these are all indices question. That's why I say all this while you have been not say living a lie but actually it's like living a lie because all the questions given to you can be changed to the same base, but in reality cannot. You see, in real life a lot cannot. So this is the reality now. Okay, so let's take a look at the reality. Base 6, base 8 cannot change to base 2 for both, cannot, right? So you have to take log on both sides, log here, log there. Then now bring this power down. Remember, very importantly, when you bring the power down, right, you see now I'm very nice. I'm very nice. You see, I put the bracket for you. Okay, but in your working, many of you will not put working, will not put bracket. You see, you don't put bracket, wrong already. Remember, brackets are very important. Okay, I repeat 3 times. Brackets are very important. Brackets are very important. Brackets are very important. You don't put bracket, it's considered wrong. Whole thing wrong, 0. Okay, why? Bracket tells us that it's actually log 6 times x, log 6 times 3. Okay, after this, what do I do? This log 6 is just a number. So I divide both sides by log 6. And then I end up with this. Okay, then I minus both sides by 3, then I end up with this. Press calculator. Now look at how I do the working. I do not bother to find out what this is first until the very last step. Okay, because I don't want to work with 5SF. Okay, I work with the exact answer, then finally then I round to 3SF. Okay, I'm going to go faster because it's quite easy once you get the hang of it. Now, this case, right, because of this number E, this number E can be found here. When you press the shift and then you press this EX, right? This one, see these two are inverse of each other. Then you get the E number, all right? Okay, so I ln both sides. It's pronounced as ln, natural log, okay, ln. So again, you see, very nice, I put the bracket for you. You must put brackets. Then I bring down. Okay, then again, ln E, right, is just 1. Why? Because log base E, log base E, right, log of E base E means E to the power of what is E? 1, no? Answer 1. Okay? So you must know that ln of E, because these two are equivalent, is just 1, no? Okay, this one you must know. Alright, now, yeah, so this is 1, right? Then you add 1 to both sides. Then you press calculator, that's all. Leave your answer in 3SF, unless otherwise stated. Okay, this one is not E, so you use log. Then you ding ding dong dong, then like that, like that, like that, like that, like that, like that. You see I work in log. Okay, so this one I'll go fast, quite straightforward. Okay, the last one already. Is it the last one? Where's my... Something seems missing, is it? Okay, never mind. Something seems missing. Never mind, we'll sort it out later. Again, you see, base 5, base 3. Cannot, right? Cannot make same base, right? Then you log both sides. Log both sides. Then you see, again, put brackets. Very important. Bracket, bracket, bracket. Bracket, bracket, bracket. Very important. Brackets, this one also put brackets. Then your expansion that you learn in the lower sec, right? You open up. You open up carefully, the so-called rainbow method. I don't know how you all learn it. Then you group all the x terms together. So you see log 5 has x, right? So I leave it here. This fella has x, so it's minus 2 log 3. 2 log 3 is a number. Okay? Then your x, you take it out. Okay, then this minus 2 log 5, right? You plus 2 log 5 both sides, you end up with 2 log 5 here. Okay, and then this whole thing, you divide by this whole thing. You press calculator, you get the answer. Alright, now when you press calculator, you must try pressing calculator with a log. Your argument, right, you must remember to close it. For example, log 3, you must close it, Okay, log 2, if you don't close it, when you calculate, for example, log 2, then you log 3, you don't close it, then there'll be error. Okay, so you need to close the brackets. So the brackets very important. Okay, now let's go to number... Okay, that's all. Okay, never mind. You go to number 5. Okay, I think number 4, that's all. Number 5 now. Number 5 is this one. Solve this. This one looks like our indices. Yeah, it is. But with a little bit extra because you need to use log. Now, this means 2 to the power of 2 times e to the power of x, right? E is a number. It's a number. This one plus this one, and then like that. Okay, so what does this mean? I don't want to work with fractions because this means 14 over e to the power x, right? Remember your indices? Okay, I don't want to work with fraction or this unknown at the denominator. So I multiply throughout. I multiply throughout by x. E to the power x. Then I get this. That's how I do it. Okay, then I convert this into a quadratic form. All right, quadratic form. Hey, I made a mistake here. Right? There's a 2 here, right? Here. So I convert this into quadratic form. Those who don't know what I'm doing, you can let m be equals to e to the power x lah. Then you will get 2m square minus 3m minus 14 equals 0. Then you m equals to something. But then you must remember later to change your m right back to ex. Then you must remember to find your x. Okay, the whole idea is not to find m. That's why I don't like this method. I don't like this method because many students, right, they let m equal or let whatever equal to this. After that, they forget to change back, then they happily say that m is the answer. No, m is not the answer. M is ex or e to the power x. And they don't want you to find e to the power x. They want you to find x. So you learn this method easier lah. Okay, how to do this? You're actually solving quadratic equation. And then you're actually factorizing here. Okay, those who don't know, then you press calculator one. Those press calculator gang, it's like that lah. It's a mode 3 that thing, right? But in this case, it's mode 5, 2, then 2. Then you press 2 minus 3 minus 14, right? Then you get 7 over 2 right there. 7 over 2 lor, then you work backwards. Then you press again. Minus 2 there. Minus 2, then you work backwards. But minus 2, you have to reject. Because how can e, which is a positive number, right, raised to something, give you a negative number? Cannot be. A positive number raised to any number will always be positive. So you have to reject this. Okay? This one, ln 7 over 2. Okay. Ln 7 over 2. You go work it out, right? It's 1.25. So the answer is 1.25 to 3SF. So always check. Sometimes you need to reject the answer. Okay? Now let's look at the second one. Now, this particular part, right, is good for revision because you have actually done all this in Sec 3. But some of you are still finding it very difficult. You should not find this difficult. No, you find this difficult, then the questions which also come with logarithm or exponential function, then you will find it that even more difficult, right? Okay, so try to master it during these holidays. Okay, so this is base 7. So try to change this to base 7, which is possible. Okay, now again, those who don't know, then you let. I see. What I do is this is 7 to the power 1 times 7 to the power x, right? So I split it into this. And then this one is actually 7 to the power x whole thing square, right? Okay, so if you don't know, then you from here you let m equals to 7 to the power x and then you work it out lor. But don't waste time lah. Can you, since you have the time, right, you try and do it this way. Okay, and then this one no need to lock. Hey, wow, those people who go and lock here, then you're not using your Sec 3 what you have learned. Or in fact Sec 1 learn already. 7 to the power of what equals to 1? 0. Anything to the power of 0 is 1 so is 0 lah. Okay, don't go and lock both sides. Lock both sides means you're not thinking, you're just doing things blindly. Okay, this one then you must lock. You lock here, lock there. Okay, then this is a number, right? Then you divide, and that's all already, that's all. 3SF. Okay, now let's go to part 3. Okay, part 3 looks difficult, but it's not lah. It's never difficult one. Okay, where is it? Part 3 here. Okay, so you see 4, then 4. Okay then we change to base 4 and then split this into 2 then it becomes like that. Okay, then this can be rewritten as 4 to the power x whole thing square because this is just 2 times x, which is 2x, right? Then everything should be on the left hand side because you are converting, not say converting, like you're rewriting this in the form ax squared plus bx plus c. So I factorize it, I'll end up with this. Okay, you try to do it this way. If you can't, then as I mentioned just now, you let m be equals to 4 to the power x. Then you get 4m squared minus 47m minus 12 equals 0. Like that lah. Okay. Now, after you have done that, then you will end up with this. And you see again, positive number to the power of anything has to be positive. So you reject this. No need to log both sides to discover that is to be rejected. No need. You from here you should know already. This one, then you can log both sides. Okay. Okay. I think I made a mistake. So we skip 4. We go to 5 first. This one same thing lah. Same old story. But you must remember these two. A lot of students they only remember the first person. They forget the second person. So you must remember to multiply for both. Okay. I didn't multiply for both. You see, I made the same mistake that I asked you to avoid. Correct or not? Yeah, you see. So you see, now here should be square, right? Yeah, square here. And down here should be square. Correct? Are they whole thing wrong already, no? Correct or not? Whole thing wrong already. So whole thing wrong already. So this should be 9. This should be 9. Okay? Then you go and work out. Terrible, wrong. So you go and rework it out. Your teacher's answer is wrong. You see? We always don't know why we human beings we only remember the first part, then we forget the second part. It's actually very real life. Beginning of the year, this is like beginning of the year, then the second half of the year is like that, So beginning of the year, you work very hard, then you remember your goals. Then later part of your life, right, you forget your goals or you give up. So don't be like that. Don't be like me like that. You must remember your goals the first half. Next year, January to June, you must remember your goals. That one most of you will remember lah. Then after that, right, the second half, some of you will give up, Some of you will give up. So don't give up. Remember your goals first half of the year, second half of the year also. Okay. So your teacher left out this, and some of you would have left out also. So make the necessary change. Okay. Okay. So this one I leave it to you. So remember, we just need to put a bracket here. A lot of people would falter here already. So avoid that. Okay. What's the next question? Question 4. Okay, question 5 here. Okay, question 5 just now I missed out, right? Okay, same thing. Question 5 is easier lah. Then you factorize, and then this one of course cannot make it, right? Positive number raised to any number has to be positive, cannot be negative. So you reject. Then the other side, you can work out the answer, and it's 1.10 3SF. Okay, now let's go to number 5, last part. Okay, this one I changed the base to 2. Why? Because the smallest base is 2. Alright, so same here. I must do first half of my life, second half of my life next year. Must both be correct. Alright, now this I break it up into 2 to the power x divided by 2 to the power 1. And 2 to the power 1, 6 divided by 2, right, is 3. So these two combine into 3 here. Okay, and I split this also. 2 to the power 2 is 4 times 2 to the power 2x to the power x to the power 2. Okay, so those who don't know one, you can let m equals 2 power x and then you work it out lah. Alright, but I really hope that you can do it this way and you get the answer. Okay, now let's move on to number 6. Number 6, we are back to this kind of question again, which requires a little bit more manipulation and thinking. Okay, now they ask you, what did they ask you? To find the value of a and b, right? Okay, so they give you this, they give you this, they give you this, they give you this. So they give you 1, 2, 3, 4 equations, and then they make you find a and b. Okay, so how do you do this kind of questions? My approach is this. There are many ways to do it. I change these two log, right, into index form. Okay, why change to index form? Because my equation 3 and 4, they are in index form. So using these two x and y, I am going to replace them with only a and b. That means I want to be left with equations a and b only. So by substituting this x and y into here, okay, I get a new equation here. And by substituting this into here, I get another new equation here, which is only consisting of a and b. Then I solve simultaneously like my lower set like that, then get my a and b already. Okay? So that's how it works. So when you see these kind of questions, it's not high level. No? It's not high level. It's just tedious. Irritating because it's tedious. Okay? And it trains you on manipulation. Alright? So try it out. And you'll be brushing up on your indices, brushing up on your simultaneous, solving equations, and then logarithms also. Okay, killing many birds with one stone. So I'll move on. That was number 6. Okay, now number 7. Number 7 almost like the same like that. All these are drill and practice questions. You are given these two, and you're given these two. So you're given 4 equations. Same as question 6. So same approach. You go and practice on your own and check answer. Okay, my answer could be wrong, then let me know. Change this into index form, x and y. Why? Because finally they want p and q only. They don't want x and y. So I replace this x and y here to get p and q. Throw this x and y here into equation 4. Get this p and q. Then I solve simultaneously, then get the answer already. Alright, so that's number 7. Now look at number 8. Number 8, we are back to logarithm, pure solving of logarithm equation. How do I do this? Okay, look at this left hand side is base 2. The right hand side, right, consists of a number 2, but it also consists of another log term with base 2. Okay, so what do I do first? Okay, I change this square root into power half first. Okay, I can straight away do everything here, but I want to do step by step for you to see. So I didn't do anything to the right hand side. Then now I bring this power down to the front. Okay, then now I do the right hand side. I'm doing step by step for you. Ayo, something wrong leh. Oh, nothing wrong, sorry. I times 2 throughout, right? Times 2 on both sides to get rid of this half. So this becomes 4, right? Then 4 times this will get this. Alright? Then I bring this power up. Why? Because this coefficient must be 1. Then I can combine with this fella, right? Okay, then I leave the number here as it is. Why? So that I can 2 to the power of 4 equals to this whole argument. Alright, then I solve, ding ding dong dong, then get the answer already. Can both answers be accepted? You see, I never reject. Very bad. So you see, you must always check the answer. Anyway, check whether my answer is correct or my answer will be wrong. You cannot log a negative number. So this has to be rejected. Okay? So that's all. Finish already, number 8. Okay, now we go to number 9. Sorry, it's number 8. There's part 2. Okay, there's a part number 8, part 2. Okay, number 8, part 2. What is it all about? Okay, solving again. So what I do is I change all this into 3 to the power x. These two I split into this. So you see, I hope you see what I mean. Once you do logarithm, and then you do indices, right? You'll find that indices is so much easier already. Okay, so our human brain is like that. Once you expose it to more difficult things, that means you stretch it further. The old stuff that you have learned, right, becomes so much easier already. Okay, so train your brain. After this, right, I multiply throughout by 3 to the power x. Okay, I multiply throughout by 3 to the power x. Why? I don't want this denominator here. Then I change it into a quadratic equation. Then I factorize and I solve and then get the answer. Okay, can both answers be accepted? Now you look at the original equation that you're given. It's not logarithm. It's not in logarithms, so it is okay, right? I don't know, you go and check it out. Okay, you go and check it out. Yeah, okay. So that's number 8. Okay, now we go number 9 already. Number 9, what did they ask us to do? Oh, you are given this, right? You are given this. So find this. Okay, now don't be too quick to log. Just because this is, you're learning log, then you go and log, happily go and log. No lah. You log when needed lah. So now you want to find out what 1 over 9 to the power of q is equals to. Then you see, base 3, base 9. You can change this to 3 square. Then you will get 3 to the power of q already, right? Because once you open up the bracket, 1 to the power of q, 1 to the power of anything is still 1, right? But 3 square to the power of q, you can rewrite as this. Then 3 to the power of q is p, right? So this is the answer already. Okay? Then next part, they ask you to express what? Log 327p square. Where is it? Sorry, I'm showing you another method. Okay, I'm showing you the long way. Just now I say don't anyhow log, right? Okay, that's how you may, they see this one, they log already. Because you know how to do log, now you log. You happily will log. Okay? Many of you will do this because you know how to do log already, right? Then you you will log both sides. I don't know why like that, but we are like that. Once we know something, we will do it. Okay, blindly. Okay, so you log 3 also can get answer. Then you bring this down, right? Then this whole thing is just 1, right? So q is equals to log p to base 3, log of p to base 3. But then 1 over 9 to the power of q is 1 over 9 to the power of q. Is this right? So you replace it here. Okay? And then 1 to the power of this, right, is just 1. 9 to the power of log of this. Remember just now we say that if this base is the same as this base, then the answer is just this. So I'm showing you this method to show you when you can use that one. Of course, this you don't need this method. You can just use this short method. But some of you, they may have used this method, so I'm going to show you how you can get the same answer. Okay. So you see 9 is equal to 3 square, right? But this 2 is now in front of the log. You cannot allow that to happen, right? You must bring the power up. So that is base 3 to the power of log of base 3. Then you can consider these 2 cancel out. So it's 1 over p square. Okay? So that's how you apply what I mentioned to you at the start of this lesson, that this is true. Okay? Now, course, please don't use this method lah. That means you see there are many ways to solve a question. Always use the shorter way lah, the most direct way. Okay, don't use a long way just to get that 1 mark, 2 marks like that. Okay, okay, so that's for 9. Okay, now we go to they want you to find this, right? This one, then you have to use logarithm. Why? Because it's given to you in log form, so I split them. Why I split them this way? Because I know 3 to the power of 3 is 27. Okay, so this is this, correct? And these are, I can bring this down. Okay, I can bring this down, and this, I also know is this Q. Correct? Because in the question you are given this, so you must use this. Which means for this 9 part 2, you still must use log. You must show this working, you know. If you didn't show this working, then you won't get a mark already, no? Okay? Unless you say, you did 9 part 1, right, using this method, then you say from part 1. You down here, you say from part 1. Like that lah. Okay, okay, now the next part, they ask you to solve this, right? Let me see the question. Find the values of Q such that, okay, so they ask you to solve this. Okay, so I rewrite again as a quadratic equation, and then I solve, I factorize, then I solve, get one answer, get another answer. Okay, you go and check it out whether it's correct or not. Okay, now number 10. Your number 10 is the same old story, but this story is slightly a little bit more complicated lah. So I would say this is the most complicated of the few that are of this kind. Okay, so let's take a look at it. Okay, you're given these two equations, right? Okay, I change them to index form. So this a to the power of 8 equals to this. A to the power of 12 equals to this. Okay, then I get these two. And what do? You see this question, I have to be able to think on my own feet. Okay, after I have these two, right, what should I do? Some students, after they get these two, they give up already. They don't know what to do. You see, you want to find, what's the question? Oh, you want to find this, right? You want to find this. Okay, so you must have log x and then log square root y. Okay, which means that you must find your x and your y. Okay, how do I find my x and my y? I need to find my x and y in terms of a. Why in terms of a? Because my base is a. Okay, so if this becomes a, then I can work things out. But if this is still in x and y, they are not the same, you see. I cannot evaluate or I cannot simplify this. So I must change the x and the y into a. So that is log of a to base a. Then I can so-called evaluate it, right? Okay, so that's the thinking that I have lah. But after I have thought about that, then how do I deal with these two? This and this are the only way I can do or simplify it, right? Neatly is to divide into times. How come I cannot add or subtract? You will find that cannot make it lah. Cannot make it because after you add and subtract, right, you can only take out common factor and all that. Cannot, you see. So you need to be smart. And in the exam, if you don't know, right, you go and add and subtract. You will find that you get stuck. Then you go and divide. There are only like a few things you can do, right? Plus, minus, add, subtract. The plus, minus, subtract, they are the same. Plus, minus, multiply, and divide, right? So these small things lah. So I go and do division and uh, multiplication, then I end up with this. Oh, I actually managed to find my y. And once I found my y, I sub into this equation 3, then I can find my x. And once I've done that, I put it inside here, sub inside. Okay, sub inside. Then I find that, hey, very nice. Very nice. Get this, get this, get this. Then get the answer already. So I hope you understand the thinking process. The thinking process is this. The question asks us to find the values of, what did they ask us to do? Or evaluate, or calculate the value of this. Calculate the value of this. Calculate value means there must be a value, a number right at the end, So in order for that to happen, this argument, right, cannot be in terms of x and y. It must be in terms of a. A. That means your x and y must be converted to a. Okay, so that's how you think. Go and try it out and then check the answer, okay? So that's number 10. Now number 11. Number 11 is our last question for the day. 11 we will learn something new, okay? Something new. Why? I don't know, because suddenly got one dy dx here. How? Never mind lah. I accidentally put here, then we will learn it lor. No choice because otherwise then waste your time. Okay. So the first part they ask us to sketch this one. Those who cannot sketch this one very sad lah. Your sec 3 is over, then you don't know how to sketch this. I think very sad how to sketch this you know that these are exponential graph. Let's revise a bit. Y equals to the power x, it looks like that correct? When the power when the power here is like positive, then it's going this way, right? And when s equals 0, anything to the power of 0 is 1. Okay? But if I put a 4 here, then this will be 4 lah. Okay? So that is how, and then this is the asymptote, right? The asymptote is here. I hope you remember asymptote. You go nearer and nearer and nearer, but you will never touch. Okay, so that was the exponential graph. But in this case, it is 3 to the power of e minus 3x. So when there's a minus here, it means that it is a decreasing function or a decay. This one is an exponential growth. This one is a decay. And when x equals to 0, this whole thing is 1. So this should be 3. Okay, so this is how you do the sketch. Remember, you must label the intercept, label the axis, label the graph. Okay, so this is a decay. Then they ask you to find what? Value of y when s equals 1/3. Okay, so when s equals 1/3, you sub in here lah. Sub in here. Okay, then you get -1. Then you press calculator, finish already lor. Okay, this is actually 3 over e. Then you press calculator, you get this. Okay, then when when y equals to 81. When y equals 81, then you put 81 here. Then you divide both sides by 3, you get this. Then because it's e, so you ln both sides. Then you bring this power down, like that. Okay, and ln e is just 1, right? So can forget about it already lah. Then you divide both sides by -3, then you get this answer. Anything wrong or why the two answers the same? Why the two answers are the same. Why I don't know. You go and check. You go and check whether correct or not. Okay. Now the third part. How the third part, they ask us to find the value of dy dx. Find value. Value means you must have an answer, numerical answer of dy dx. Okay, now let me explain what is this dy dx. This dy dx, right? Actually, it's actually d dx of y, of this function y. What am I talking about? This d over dx, right, is an operator. Operator. What is operator? This d over dx is an operator. What is an operator? Example of operators are plus, minus, divide, times. All these are operators. Sorry. All these are operators, okay? So this d over dx is an operator. What does it mean? It means differentiate. This d over dx means differentiate with respect to x. I repeat, it means differentiate with respect to x. Okay, so when I ask you to find dy dx of this, it means I dy dx this side and I dy dx this side. Whatever I do on the left, I do on the right, right? So I d over dx on the left and I d over dx on the right. Okay, don't worry too much. You will learn more about this next year, but you just know how to differentiate exponential first, okay? Because next year, there'll be a lot of things to memorize. You'll be very, not say you'll be very you may be a bit stressed. So try to spread out your learning now. You learn a little bit first. Just like that time I asked you to learn the trigo, right? Then many of you never learn. Then you suffer towards the end because too many things already, okay? So please learn from our lesson. You learn a little bit now. Okay, now how to differentiate this? Okay, this part requires a bit of explaining. Okay, you look at these three times e to the power of minus 3x. Now, what does this mean? Okay, this y equals 3e to the power of minus 3x. This whole thing actually consists of two functions inside. We call it function in a function. There's this function inside a function. Okay, what am I talking about? There's a function inside a function. What am I talking about? Okay, to give you a clearer idea, this 3 to the power x is like gx. Okay, gx this 3 to the power, this one. This 3 to the power of e to something, right? Is actually the outer shell or the outer function. That means 3 to the power of e, 3 times e to the power of something. This is my gx. Okay, but inside this here, inside this bracket here, right, there's another function inside. Okay, so there is another function inside. So I call it f. So this is what we call function in a function. What is my fx? My fx is my minus 3x. No need to put bracket. No need to put bracket. Sorry. Okay, what is my gx? My gx is 3e to the power of something. But that something, right, is my fx. You're clear? That means this one minus 3x, right? Minus 3x alone is a function. Because it's something like y equal minus 3x. This is a function, right? A function, right? Correct? But 3, okay, don't call it 1, I call it m. 3 to the power e of something also is a function, what? So this is a function inside another function. Okay? And who is inside? Who is inside who? This f is inside this e. Okay? The f is inside, sorry. The f is inside the g. which is E lah. Okay, the F is inside the E, which is the G. You got it? Okay, it's something like this. It's something like, you know when you press calculator, right? When you press calculator, the fraction, let's say 5 over 2, right? This is a fraction, normal fraction, everybody can understand. But sometimes there can be a fraction inside a fraction. 5 over 7. Okay, fraction inside a fraction, correct or not? Can see, I hope you all can see. I think can. See, it's a fraction inside a fraction. So who is the main fraction? The main fraction is this bracket over 2. This is the outer shell. The inner shell is 5 over 7. Okay? I hope this is clear to you. Okay, you don't understand, you ask me. Next time we do some more. Let me see. Okay, I give you some example. Give you some example. This one is something new. I give you some example. Okay, you listen carefully. Very simple one. Very simple. This one is like next time you see this, you laugh. Very simple. Okay. So let's say example 1. I give you a function y equals to e to the power of 2x. Okay, y to the power of e. Y is equals to e to the power of 2x. Sorry, let me repeat that. Y equals e to the power of 2x, right? The main function or the outer shell is the e to the power of something. Then the inner shell is the 2x. So what I do when I differentiate with respect to x, right? You see, differentiate with respect to x. It means that I have to differentiate the left and the right with respect to x, right? When I differentiate the left hand side with respect to x, it's just dy over dx. But actually it means d dx of y. D dx of this one. So when I differentiate the right hand side with respect to x, okay, very simple. When you differentiate exponential function, right? When you differentiate exponential function, everybody listen. It's exactly the same old story. Whatever you see is whatever you get. Let me cover this. Okay, whatever you see is whatever you get. Okay, so when I differentiate this function, I differentiate the e function first. So when I differentiate the e function, it's exactly what I see. I just copy down. Okay, but I have to multiply it by, now I differentiate the other function already, the inner function, and that's 2x. How to differentiate 2x? Remember we learned something like that this year. Y equals to, let's say, x squared, right? I told you dy over dx is just bring the power down, power reduced by 1, right? So answer is 2x, right? Okay, let's say it is y equals to 4x, dy over dx, right? Sorry. We were looking at my hand, sorry. Okay, sorry. When you differentiate dy over, when you differentiate y equals to x squared, dy over dx, right? You bring the power down, that's 2, right? Then power minus 1. Then you get 2x. When you differentiate this y equals to 4x, power is 1, right? Bring the power down, 1 times 4 is 4. Power minus 1 is 0, so answer is 4, right? Okay, so let's try it out here. When I differentiate 2x, 1 bring down, 1 times 2 is 2. Then 1, the power minus 1 is x to the power 0. Anything to the power 0 is 1, so answer 2. Answer is just 2 times e to the power 2x, that's all. Okay, I know maybe you're a bit confused. We do a bit more. Okay, let's say I give you this example. Y equals to 10 times e to the power 2x. Okay, so the outer shell or the outer function, right, is the exponential function. The inner one hiding inside the exponential function is this linear function minus 2x, right? Okay, so I differentiate this, means it's just this. It's exactly what I see here. Can you see that this is just photocopy put here? Exactly the same, huh? Exactly the same. But I need to multiply by the inner function now. Inner function is minus 2x. Okay, so 1, I bring down 1 times minus 2 is minus 2. X to the power 1, the 1 I minus 1 is 0. Anything to the power 0 is 1. So the answer is just minus 20 to the power of e to the power of minus 2x. That's all. Okay, I give you another example. If I want to find the dy dx of this, differentiate x with respect to x. This is the outer function. The exponential function is the outer function. The inner function is the, sorry. This is the outer function, the exponential function now. The inner function is the minus 12x squared. So I do the outer function first. Next time I will teach you lah. I call this the Durian Rule. Durian. You know durian? Durian, you know durian lah. The one with the spikes one. It's a fruit. Can find in Malaysia, Thailand, Singapore. Singapore not much and not rectangular. Durian is round color. Not round color. round in shape. Okay. So durian, you know durian. To eat the durian, right, you need to use a knife and attack the outer shell first, right? Sorry. Outer shell, the outer shell, you attack the outer shell, right? Then after the outer shell open already, then inside, then you attack the fruit, right? Inside got the fruit, so we always attack outer shell first. Then later, then you attack the fruit. Okay? So this outer shell is the exponential function. Exponential function inside, then there is another function minus 12x squared. Okay, so when I differentiate this whole thing, I must differentiate the exponential function first. But very funny one, when you differentiate the exponential function, you get exactly what you see. Whatever you see, you get exactly. That's why I'm very happy. You know what I mean? Okay, never mind. We'll go through more next lesson. You differentiate this, right? You get exactly, whatever you see here, you get exactly for exponential function. Then you need to multiply by minus 12x squared, right? You bring the power down, multiply 2 times minus 12 is minus 24, right? Then 2, the power 2, you go and minus 1, you get 1, right? So your final answer is number times number, then x remains, and then this one just remain. So that's all. So that is called differentiating the exponential function. Actually, in mathematical terms, it's called the chain rule. But I call it the Durian. You know why? Because the outer shell, then the inner shell. So I attack the outer shell first, right? The durian shell first. Then later I attack the fruit, right? Or you can think of it as coconut. You know coconut? Coconut, you attack the shell first, the husk. Then you remove all the husk. Then inside, then you eat the fruit, right? Then you drink the coconut water, right? It's the same thing lah. Okay? Maybe I give you one last example. Y equals EX. If I were to ask you to differentiate this with respect to x, right? The answer is just e to the power x. Why? Because the outer shell is exponential, then the inner shell is x, right? So I differentiate this, it's just this. Then I multiply by, you differentiate x, it's just 1. So the answer is just e to the power x. Okay, now we do one last one already. Very easy one. Minus 5x minus 2, like that. So when I differentiate this, it is just whatever I see, I get exactly the same thing. That's for exponential function. Very easy one. Okay, but the outer shell is an exponential function, right? But there's an inner shell. Where's the inner shell? The inner shell is this one. That means there's a function inside this exponential function. This is a function. Function in a function. This is another function. Okay, so now I have to differentiate this inside that function. So the durian shell I attack already, right? Now I attack the fruit. Very easy. 8x. Hey, must put bracket. You don't put bracket there already. 8x minus 5x. Then 2. 2 is x to the power 0, right? X to the power 0. 0 times minus 2 is 0. So that's it. Okay? Wrong. This one is 5, right? Because 1 bring down and then that's all. So the answer is simply 8x minus 5. Must put bracket. You don't put bracket, die already. Wrong. Like that. Okay? If you don't understand, you PM me. Okay, next time then I show you more. Okay, quickly. I think, 1 hour plus already. Okay, very tired already. I think we finish this story and then we go rest already. Okay, dy dx. So back to the question. Okay, everybody back to the question. Question number 11 part 3. They want me to find the value of dy dx when y equals 1 over 27. Okay, so never mind. I find dy dx first. So if I dy dx on the left, I must dy dx on the not say dy dx. If I differentiate x with respect to x on the left, I must differentiate with respect to x on the right. Okay. So don't get confused. This dy dx, right? They are not joined together one. They are actually split like that one. Okay, it can be quite confusing. Next time then I tell you with another question. Okay, so how to differentiate this? Can you all pause the video and think? Okay, can already. So the Durian shell is the exponential function. So if I differentiate the exponential function, I get exactly the exponential function. Very happy, right? Very easy. This is like the easiest thing in differentiation. Whatever you see is whatever you get. Okay, so I differentiated the outer shell already. Now I must differentiate the minus 3x. How to differentiate minus 3x? It's just minus 3 lah. Okay, then you combine them together, you will get this. Okay, so that's what I have for now. But now I have a problem. This question very irritating. They say when y equals 1 over 27, but I don't have a y here. My dy dx is in terms of x. So how? That means I must do extra work already. Okay, I must go and substitute y equals 1 over 27 because they only give me the y value. They didn't give me the x value, so I myself must go and find, you see. So take note, we are revising now this logarithmic form. So I put 1 over 27 here, divide, I make this e to the power 3x the subject, I'll get this. Okay, then I ln both sides, I'll get this, and then my x is this. Okay, but then now I have a problem. What problem? When I sub this x here, this here, class, you see, I work in exact form. I didn't change to what you call that? Decimal. I didn't. Why? Because the question may force you to give the exact form. See? If you write in decimal, you won't be able to get my exact form. Okay, so let me show you how to do it. This question is a little bit tough for you at this stage. Okay, so now I substitute these. Okay, wait. Okay, now I substitute this right into this x here. Okay, put here already. Then minus 3 times this, I get minus this, right? Okay, now remember we said that we cannot have not say we cannot have, we said that the coefficient of this must be a 1, but now it's minus 1 there, so cannot, right? So I bring the minus 1 up here using the power law. Alright, then now see, base e, right? Base e we just learned, right? They actually cancel each other out, right? So this is just 81 to the power of minus 1. So you can get the answer as this. Can you go and check whether my answer is correct or if my answer is wrong, let me know. Okay lah, we will stop here today. Almost two periods already. Okay, I'll continue tomorrow. Thank you very much. Anything you don't understand about any of the question 1 to 11, you PM me here. The next few videos, right, I'll go through the rest of the questions, including logarithmic graphs, okay, which you need to know how to draw. All right.